Hi guys, in this video I'm going to show you how to test a table of values to see if they're linear, or another way of saying it is test the following data, this is data, to see if they're linear. My name is Dr. Tim Kruse. I'm here to try to explain this a little simpler for you. Alright, first of all, let's start in this lesson here. What does it mean by linear? Well, you guys can see the word line right there. Alright, it's linear if I plot these points and those points line up. If they line up, they're linear. If they don't line up, if I plot a bunch of points and maybe it curves upward like an exponential growth curve, which we'll talk about in another lesson, if they don't line up, then they're not a line, they're non-linear. Okay, so let's take a look at this simple graph, the ordered pair 1, 1, 2, 2, 3, 3, 4, 4, ordered pairs. Guys, ordered pairs, it's a pair of numbers. All right, it's two numbers in a certain order. That's X and Y. It comes alphabetically. All right, X before Y. So an ordered pair is a pair of numbers in a certain order, and that order is alphabetical. So if I plot 1, 1, I'm going one step to the right and one step up. A little review of graphing here. 2, 2 is two steps to the right and two steps up. 3 steps to the right and 3 steps up. 4 steps to the right and 4 steps up. Do they line up? Yeah. So yeah, I can say this is linear, but we don't always have a piece of graph paper and we don't always have the time to graph. So we need to figure out a way of doing this without graphing every single time. All right. Probably the easiest way to figure out if a table of values is linear is just check the slope. Because on a line, the slope's going to be the same all the way up or down that line. Let's check the slope from 1, 1 to 2, 2, just visually first, and then I'll kind of show you how to work it out mathematically. So checking the slope, I'm going to go one step up and one step over, one step up, one step over. I'm going to say my slope is 1 over 1, which we're just going to shorten to 1. Okay? So I have a slope of 1 there. If I check the slope in any other part of the line, I should get the same slope if it's linear. So I check here, I need to go one step up and one step over. M is again 1. Check it again. One step over, one step up, one step over, and M is again 1. So visually I can see if it's a line, if I check the slope, then the slope never changes. 1, 1, 1. I can check the slope between any pair of points in the table, and no matter where I check it, that slope should be the same. So let's do it mathematically this time instead of drawing a graph. All right, so how do we test the slope or check the slope and make sure it's the same all the way up the line without drawing this graph? We just use our slope formula here. Now, slope formula is just the change in y over the change in x. It's rise over run. You guys can remember rise over run. I think every math teacher you've ever had has said rise over run. So rise rhymes with y's. That's how I remember that the y's go on top. I need the difference of the y's over the difference of the x's. Rise over run, y's over x's. So rise and y's kind of rhyme. All right, so I'm going to subtract the y's on any pair of points. I'm going to start with these 2 points right here. All right, here they are on the table, 1, 1 and 2, 2. And I'm just going to go y minus y, that's 2 minus 1, y minus y, over x minus x, and that's 2 minus 1 as well. We simplify the math, 1 over 1, that's just 1. We have a slope of 1. Now, I'm going to check 2 more points and check 2 more points, and as long as the slope doesn't change, then I can say, yeah, the slope's the same all the way up. That's a straight line. That's linear. All right, I'm going to check the slope from 2 to 3. This is my little notation here. It just says which x's I'm looking at. So I did the slope from 1 to 2. That's this one to this one. Now I'm going to do the slope from 2 to 3. That's from here to here. So I'm looking at these 2 points here, 2, 2, and 3, 3. This point and that point on the graph. All right, look at your y values. Subtract them. So 3 minus 2, 3 minus 2. Over 3 minus 2, 3 minus 2, so y's over x's, I get the same thing. Now I want to show you that you can start at a different y if you want to. Like on this one right here, when I'm measuring the slope from 3 to 4, I'm using these 2 points here. I can start with 4 and subtract 3 for my y values. But just to show you that if you do it backwards, it's okay. If you want to start with 3 and subtract the 4, that's fine. Just make sure that if you go in this order on the y's, that you go in the same order on the x's. That's all you got to remember. So if I choose to start with 3, I'm going to go 3 minus 4, y minus y, over 3 minus 4, x minus x. Just go in the same order, use the same pattern. If you start with this y, you got to start with that x. All right? Now this one here, the math is a little trickier. I end up with -1 over -1. But you guys remember a negative divided by negative is a positive, so it works out. So it doesn't matter which y you start with when you're using your formula. Just make sure whichever y you start with, that you start with its partner x on the bottom. All right? So slope is 1, slope is 1, slope is 1. I can say, in my head, without graphing it, I can say, well, that's got to be a straight line because the slope never changes. All right, guys, I put up a couple here for you to try. So here in just a second, pause the video. Go ahead and work both of these out and test them to see if this table of values is linear and if this table of values is linear. All right, one of them is and one of them isn't. So go ahead and work on that real quick. Pause the video and try it on your own. All right, hopefully you paused the video and worked these out on your own. This first table of values, this is not a linear set of data values. Now, how do you figure that out? Just check the slope, check the slope, check the slope. So check the slope between 215 and 414, and then check the slope between these two pairs, and then check the slope between those two pairs. So I have it worked out here. The slope from x equals 2 to x equals 4, so I'm checking these points right here, is y minus y over x minus x, works out to -1/2. Now, if they all work out to -1/2, then I can say it's linear. So I check the slope from 4 to 6. All right, from 4 to 6. All right, I did this one, 12 minus 14 over 6 minus 4. Y minus y over x minus x. And this time it changed to -1 after I simplified it. I already know it's not linear, but I'm just going to go ahead and check the third set of ordered pairs. So the slope from 6 to 8, from x equals 6 to x equals 8, I did this one backwards just to show you it doesn't matter. Y minus y over x minus x. 12 minus 9 over 6 minus 8. Works out to 3 over -2. By the way, this is bad grammar in math. We never leave a negative on the bottom. All right, and you can put this into your calculator and it will straighten it out for you if you want. But just remember, we never leave a negative on the bottom. All right, a positive divided by a negative is a negative fraction. It's better if we leave the negative on top. Negative divided by positive is also a negative fraction. These are both saying the same thing. They're both negative fractions, but leaving a negative on the bottom is bad grammar. All right, so always move your negative either up to the top or you can put it in front of that fraction bar if you want. But the point is, the slopes change. All right, this is something else. There's something else going on here. It's not a line, so we say that's nonlinear. Over here, this one worked out just fine, and you guys can check the math. It works out to 3 over 2 every single time. I did this one backwards. All right, I did 8 minus 11 over 3 minus 5. It's kind of a harder way to do it because you wind up with a negative on top and a negative on bottom. Just make sure you pop that in your calculator, and it'll straighten out the signs for you. Negative divided by negative is a positive. So this goes up 3 over 2, up 3 over 2, up 3 over 2. It always goes up 3 over 2. That qualifies it as a line, linear. All right, and the last one I want to show you is just, I want you to be prepared. Sometimes they try to trick you. They'll give you a table like this. Now I've kind of written X and Y out to the side here, but they'll say, okay, on this date, maybe this person made this much money, called income, all right? So in 2009, they made $76,000. And in 2010, they made $81,000, so that's good. Their income's going up. In 2011, it goes up. In 2012, it goes up. So this person's income is going up, 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 all right? That's kind of related to slope, remember? You want to see what's happening. If it's going up, 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 our slope should be positive. And if it goes down, 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 our slope should be negative. So we need to kind of think ahead and expect a positive slope on this one. Now, the trick is sometimes they say, I don't really want you to use the years for your x. They'll say something like this. They'll say let D, D for date, let D be the date in terms of years since 2009. So they don't actually want you to use 2009, all right? They want you to use the years since then. Well, let's talk about this one right here. How many years is 2009 from 2009? 0. That's our starting point. We call that initial value a lot of times. Back in junior high, you called it a y-intercept, all right? So how many years is 2010 since 2009? How many years since 2009? Well, this is 1 year later. That's 1 year after 2009. This is 2 years later, and this is 3 years later. So lots of times, don't let them trick you. They'll give you the original information like this, but what they really want you to use for your x values are 0, 1, 2, 3. All right? You check the slope the same way. Sometimes they'll call it D for date. I forgot this. Sometimes they'll call it D for date, or sometimes they'll say T for time. All right? But it all means the same thing. They're basically just saying, don't use the years. Use how many years have passed since we started this experiment or this measurement or whatever. This is when we started measuring, and this is 1 year later, 2 years later, 3 years later. All right? So don't let them trick you when they try that. Calculate the slope the same way. So I'm using these values over in this table, our corrected table. And y minus y over x minus x works out to be 5,000 every time. Note here that I kind of did it backwards on this last set. I started with the smaller number. It might be something you guys need to think about. When you start with the smaller number, lots of times you'll run into a negative, which is kind of scary for some of you. So 86,000 minus 91,000 give me a negative 5,000. Just think about that. Try to start with the larger number if you can. So, lots of times you can't do anything about it. But try and start with the larger number if you can and subtract the smaller number, and that way you're only dealing with positive numbers. It doesn't happen every time, but do it that way if you can. So starting with the smaller number, I end up with a negative 5,000. And starting with the smaller number, I end up with a negative 1. Remember not to leave your answer like this, all right? Never leave your answer like this. This is bad grammar. Anytime there's a negative on the bottom, it means you got to take one more step and straighten that out. All right, your calculator will do it for you, or you can remember that a negative divided by a negative is a positive. So since our slopes are 5,000 each time, let's think about what that means. This person's income is going up $5,000 for every year that goes by. 5,000 per year. 5,000 per year. That's how slope works. Slope is basically asking what's happening each year. All right, what's happening as each unit of time goes by. So this person's income is increasing in a linear fashion. So we say this is a linear model. All right, okay, that's it.